Recently, we talked about how electricity flows and transmits energy from one point in a circuit to another. But how exactly can we quantify the amount of energy that has been transferred in any given amount of time? Well, when current flows through a circuit component, such as a resistor, the electrical energy that is consumed by the component in a specified time is defined as the product of the voltage across the component and the charge that has passed through that component in that time period. This extends from the definition of voltage. To calculate the charge that has passed, simply multiply the current flowing through the component by the time period in seconds. This is because we defined current as charge flowing per unit time. Thus, charge itself is the product of the two. So, electrical energy consumed by any circuit component can be expressed in terms of the voltage across it, current through it, and the time period in question. This energy is measured in joules and is converted to different forms depending on the component in question. For instance, resistors convert it to thermal energy. Bulbs convert it into electromagnetic radiation or light. Electric motors convert it to kinetic energy, and so on. The rate at which this energy gets converted to other forms is known as electrical power, and it's the quantity that we are concerned with in most cases. Electrical power is defined as the rate at which electrical energy gets dissipated by a component. By doing a simple substitution, we can see that electrical power is the product of voltage across the component and the current flowing through it. Power is measured in watts, which are the equivalent of joules per second. So, provided the power that a component dissipates, we can also obtain the electrical energy that it consumes over a certain period of time. When too much power is dissipated in a component, it might burn up, causing the wires within it to melt, resulting in an open circuit. This is simply a gap that blocks current from flowing. This is why most electrical components have a label with a power rating written on them. Even resistors have a power rating, and when designing electrical circuits, you should make sure that the maximum power that you expect to be dissipated from a resistor is about half its power rating, lest you fry the resistor. These concepts are crucial in circuit design, and they also apply to how you are charged for your electricity bill. Here, the amount of electrical energy you use is expressed in kilowatt hours. This can be converted to joules by multiplying this number by 1,000, and also by 3,600 seconds for every hour. This gives you a value in watt-seconds, which is the equivalent of joules. So, you pay for energy usage, not power usage. What this means is that you can use appliances that consume a lot of power, thus using up your energy faster, or use low-power appliances for extended periods of time. In both cases, the energy consumed is the same, but the appliances will operate for different lengths of time due to different power consumptions. That's it for the basics of electrical energy and power. Thank you for watching.